So here we go with the similar triangles and trigonometry review portion of the final review. Now these two obviously are not triangles, but they are polygons, and they tell us that they are similar. They want the scale factor of the smaller figure to the larger figure, which means I'm going to put the small measurement on top and the large measurement on the bottom. So if I look at this, I need to pick a side from the large and the side from the small that are corresponding, that I have both measurements of. In other words, I could pick the 24 and the 20, or I could pick the 42 and the 35. I couldn't pick this 42 because I don't know what that measurement is. Technically I do, but we just want to go with what's given. So I'm going to use the 24 and the 20, and the measurement that's from the smaller figure is the 20, and the larger figure is the 24. Now if I reduce that, I think I can divide by 4. If I divide by 4, I get 5/6, and that's my scale factor. Now sometimes scale factor is listed like this, so you'll have to see on the test what it is situated as. It cannot be 6/5 because that would be the reverse of smaller to larger, and it says specifically smaller to larger. So same deal over here, small over large. So a small measurement and its corresponding larger measurement. So small would be 5, corresponding large would be 10. That reduces to 1/2. Scale factor would be written like that, or like this. Okay? All right. Find the missing length. So I'm going to call this missing length x, because I like solving for x. And if you notice, I have two triangles. I have a small triangle here. I also have a larger triangle, which is the whole triangle as a whole. And I'm going to use some sides. So I know that if they're similar, that the small side over the corresponding long side, now which we would call x plus 10. So 10 over x plus 10 is equal to the small side over here, which is 8, over the whole thing. What's 8 plus 16? 24. How do I solve something like this? I cross multiply. So 8 times x plus 10 is equal to 10 times 24 is 240. It gives me 8x plus 80 equals 240. Subtract my 80. Running out of room here. That gives me 8x equals 160, and if I divide by 8, I get an answer of x equals 20. Sorry, I kind of ran out of room there. All right, same deal over here. This point at the top, I kind of want to think of it as though this is the point at the top, so I'm going to do this over the whole thing, which the whole thing would be 5, is equal to this over the whole thing, and they give me the whole thing as 10. So I'm going to call this x, that's the one I'm looking for. So I'm going to say 4 over the whole thing of 5 is equal to x over 10, and this one's a little bit simpler to figure out. I get 5x when I multiply here equals 4 times 10, which is 40, divide by 5, and I get an answer of x equals 8. Okay? All right, solve for x. The polygons in each pair are similar. Now I'm just going to go ahead and get a new piece of paper here because I know I'm going to need more room to write. Now if they are similar, I should be able to set up fractions. So in other words, I should be able to put 12 over x plus 6, 12 over x plus 6, and set it equal to another fraction of corresponding sides. Now there's nothing to go along with the 15, but I can set up 16 over 24 and go from there. So if I multiply 16 times x plus 6 and set it equal to 12 times 24, I get 288, and I'm going to solve from there. 16x by distributing plus 16 times 6 is 96 equals 288. Move my 96. 16x equals 288 minus 96, 192. Divide by 16. divide by 16, and I get x equals 12, and that would be my answer there. So for number 5, I got x equals 12. Okay. Number 6, same deal. I can set up a fraction. I can put 5x minus 5 over its corresponding side would be 14. Set it equal to 25 over 10. And do my cross multiplying. So I have 10 times 5x minus 5 equals whatever 14 times 25 is, 350. So 10 times 5x would be 50x minus 50 equals 350. Add 50. 50x.
Marcella, Marcus.
Sorry about that. 50x equals 400. Divide by 50. And x equals 8 for this problem. So for number 6, I get x equals 8. So we got a lot of cross multiplying in these problems. Okay? All right. Next problem. State if the triangles in each pair are similar. If so, state how you know they are similar and complete the similarity statement. Now, one thing I notice here is I have 2 angles that are congruent. I also have 2 other angles that are congruent because I have what we call vertical angles. Whenever you have that kind of bow tie idea, or sometimes I think of kissy fishies, they're fishes that are kissing, these 2 angles are going to be congruent. So if I have 2 angles that are corresponding with 2 angles there, I have angle-angle similarity. That would be my reason why they are similar. Now I just need to complete my statement here. Triangle JKL is similar to triangle. J corresponds with J in the other triangle. K would correspond with E. And L would correspond with F. So that would be mine. Let's see, over here we have angles that are congruent. That's good. Now let's see what we've got going on. If I take 81 and I put it over 16, let's see what that reduces to. It's an improper fraction. It's just 81 over 16. That doesn't help me. And 72 over 18. 72 over 18 is 4. Over 16 and 72 over 18. These 2 are not similar, I don't believe. However, let me check one more thing. I am not 100% sure that 81 and 16 are corresponding. I think that the triangle may be flipped because to me it looks like that's the longer measurement. Of course it's the longer because it's 18 and that one's 16. And this is the longer, so I actually was comparing the wrong things. So I'm going to take 81 and compare it with 18. And then 72 and compare it with 16. That should be the way it goes. So we've got a tricky one there. It's flipped. 81 over 18 is 9/2. And 72 over 16 is also 9/2. So we do have similarity. So I have a side that's proportional with another side. And another set of proportional sides, and I have an angle included, which means I have side, angle, side similarity. So SAS would be my reason. So triangle LMN, this is where things are going to get a little tricky. L corresponds with C. That should be pretty straightforward. Now, M is at the other side of the short leg, or the short side. So the other side of the short side is D for this one. And then my last point would be E. So there's my triangle. All right, now we get into some trigonometry. Remember our favorite word. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So find the value of the trigonometric ratio. I need to find the cosine of C. So here is C. I need adjacent and hypotenuse. Now C is made up of 2 sides. Every angle is made up of 2 sides. One of those sides is the hypotenuse. That would be this guy. The other one is your adjacent. Across from it is always your opposite. Therefore, cosine of C is equal to adjacent over hypotenuse. And there's my result. Okay, let's turn to the back. Sine of x, I'm going to write SOHCAHTOA up here again just so I can refer back to it. So, sine of x, I need sine. Here's x. Here's my adjacent, hypotenuse. I'm sorry, not hypotenuse. Hypotenuse is over here. And this is opposite. So I need opposite, which would be 30, over the hypotenuse, which is 50. That reduces to 3 over 5. Here we go with the next one, tangent of C. So here's C. I need hypotenuse, opposite, adjacent. And for tangent, I need opposite and adjacent. So tangent of C will be opposite over adjacent. And I can divide both of those by 7, and it reduces to 4 over 3. And down here, sine of x. Here's x. I have adjacent, hypotenuse, and opposite. Sine is, I'm running off my page there. Sine is opposite over hypotenuse, so opposite over hypotenuse, and that fraction does not reduce because 41 is prime. Okay? All right, find the missing side. Notice I'm going to have to use trigonometry because if these are right triangles, so I could use Pythagorean theorem if they gave me 2 sides. I could find the third side, but they don't give me 2 sides. Therefore, I'm going to need to look here. Here they give me the opposite, and the other one I'm concerned about is adjacent. What uses opposite and adjacent? Tangent. So I'm going to say tangent of 39 degrees is equal to opposite over adjacent. And the way I solve this, I'm going to multiply by x. That gives me x times tangent of 39 degrees equals 14. Divide both sides by tangent of 39. And that gives me x equals 14 divided by tangent of 39. It says round to the nearest tenth, so I'm going to say that x is 17.28, would round to 0.3. That's the value of my missing side. Okay. Number 14. Here's my angle. Opposite and adjacent is what I have. What uses opposite and adjacent? Still tangent. So tangent of 56 degrees is equal to opposite over adjacent. This one's a little simpler because since the x is on the top, all I have to do is multiply by 18 to get it by itself. So in my calculator, sorry, it keeps glaring. I gotta find a good place to put it. 18 tangent 56 is 26.68, which would round off to 26.7. Okay. All right, number 15. They give me opposite and hypotenuse. What uses opposite and hypotenuse? That would be my sine. So I'm going to use sine for this one. So sine of 19 is equal to opposite over hypotenuse. Multiply both sides by 16. And this is another one like the last one where I can just plug it all straight into my calculator. So 16 sine 19 gives me 5.20. That would be 5.2. Okay. And finally this one I have opposite and I have hypotenuse. Again, opposite and hypotenuse is sine, so I'm going to say sine of 46 is equal to 13 over x. Multiply both sides by x. This is like that first one, number 13 that I did. It's going to take a little bit more work. Sine of 46 equals 13. Divide both sides by sine of 46. And x equals 13 divided by sine of 46. I get 18.07, which we would call 18.1. Okay. All right, find the measure of the indicated angle. So here's the angle that I'm looking for. And let's see, they give me the opposite and they give me the adjacent. That would be tangent. Tangent is opposite and adjacent. So I'm going to say tangent of theta is equal to 17 over 48. And when I'm looking for the angle measure, this is where I have to use that shift tangent or the tangent -1 thing, sometimes also known as arctangent of 17 over 48. And it says find our answer to the nearest degree, so I'm going to round it to the nearest nice number. So I hit second tangent, and I get that -1 thing. 17 over 48. 19.5, we're going to call that 20 degrees. So that missing angle is 20 degrees. This one right here, let's see. Here's my angle. They give me opposite, and they give me hypotenuse. What uses opposite and hypotenuse? Sine. So I'm going to say sine of theta is equal to 4 over 5. I have to use my inverse sine, that -1 thing, of 4/5. That's going to give me my result. So second sine of 4 divided by 5, 53.1, I'm going to call that 53 degrees. So when it says the nearest degree, they're wanting the nearest nice number. All right, next one. They give me adjacent and hypotenuse. So adjacent and hypotenuse, that would be cosine. So cosine of theta is equal to 45 over 57. I'm going to use my inverse cosine. And go to my calculator. 45 over 57. 37.8, we're going to call that 38 degrees. Okay, and the last one in this set, they give me opposite and hypotenuse. So that would be sine, so I'm going to say sine of theta equals 6 over 25. Use my inverse sine. And that will give me theta. So second sine 6 divided by 25. 13.8, we're going to call that 14 degrees. Okay. All right, this next one I think I might need my scratch paper again because I need a little more room to write. So, find the length of the side labeled x. Now, x is part of this triangle over here. I think I'm going to be able to use the angle stuff that I have, the SOHCAHTOA stuff, if I were to know the measurement of this side. So I'm going to find the measurement of this side. I actually don't need to worry about that. I can find it either from over here. Yep, need to find it from over here first. So that way I can get a number there, and then once I have a number there, then I can use it here. So if I use this 25 degrees, I have opposite and adjacent. That's tangent. So tangent of 25 is equal to opposite, which I'm going to call that x, over 15. Multiply both sides by 15. And x equals, let's see, round your values to the nearest tenth. Okay. So 15 tangent 25. And I get 6.99. We'll just leave it as 6.99 for now. Even though it says nearest tenth, I'll round to the nearest tenth when I'm done. So if this is 6.99, I'm now looking at this triangle right here that has 35 degrees, a right angle here. This is 6.99, and I'm looking for x. So again, I have opposite and I have adjacent. That is tangent. So I'm going to say tangent of 35 is equal to x over 6.99. To get x by itself, I'm going to multiply by 6.99. 6.99. Now, if I didn't clear my calculator, that makes life good. Do you see how it already has that 6.99? All I have to do is press times tangent 35, and I've got my answer, which is 4.89. Now I'm going to round it off to 4. Can't write and talk at the same time. 4.9 as my answer there. So x equals 4.9 as my result there. Okay. All right, next bad boy. Let's see. X is over here. I think, again, I'm going to need to find this value. And I'm going to have to find it from this triangle and then apply it to this triangle. So if I call this X for right now, I'm going to say that I have adjacent and hypotenuse. That would be cosine. So cosine of 68 degrees is equal to adjacent over, let's call that Y, just so that it's different than the X I'm looking for. Over hypotenuse, multiply both sides by 32. So that height value is equal to 32 cosine 68. 11.98. Now again, don't clear your calculator because you might be able to just hit times something and that keeps your accuracy. So I now know this. This is the adjacent and the hypotenuse of this triangle. So that's cosine again, adjacent and hypotenuse. This time it's cosine of 53 is equal to y over x. And I know that y is 11.98, right? I know that's a funny looking 9. So now I'm going to multiply by x, and that's going to get me x times cosine 53 degrees equals 11.98. Divide both sides by cosine 53. And x will equal, I already have the 11.98, so this time I just have to hit divided by cosine 53. And I get 19.91. We're going to call that 19.9. Okay, so here I get x equals 19.9. All right, now last two, solve the triangle. Now, solving the triangle means that you are finding out all missing sides and all missing angles. To me, it's a little hard with these not labeled, so I'm going to go ahead and give them labels just so that I'm able to know what I'm talking about. I always label that right angle as C. I'm going to do it in the other problem also. The other two, it doesn't matter which one I call A or which one I call B. So I'm just going to go ahead and throw an A and a B on those. Since it's a right triangle, let's see. To solve it, I need to know big A, big C, big, how about we go in order? Big B and big C. And I also need little a, little b, and little c, keeping in mind that the capital letters represent angles, the lowercase letters represent sides. So, what sides do I know? I know side C is 30. That's the side opposite big C. Big C is 90 degrees. I know little b is 29. If I have two sides, I can use Pythagorean theorem to find the third side. So I'm going to say a squared plus 29 squared equals 30 squared. And let's see what we get. 29 squared is 841, so a squared plus 841 equals 900. 900 minus 841, whoops, 900 minus, goodness, 900 minus 841 is 59, so a squared is equal to 59. That means that a would be equal to radical 59. So it's ugly, but it is what it is. Okay. Now, let's see. I know what C is. Let's find angle B. Okay. And I'm going to use the two values they give me. They give me the opposite and they give me the hypotenuse. That would be sine. So I'm going to say that sine of B is equal to opposite over hypotenuse, and this is where I use that inverse sign. So second sine of 29 over 30. And that gives me 75.2, we'll call it 75.2 degrees. That's my B value. And I should be able to find the third one very easily, just 180 minus 90 minus 72.5, and that third angle is 17.5 degrees. Okay. All right, over here again, I need big A, big B, big C, and little a, little b, and little c. So let's see, what do I have? I have little c is 53. So that's across there. And little a is 50. I know that big C is 90 degrees, and I got to find the rest of them. So again, I'm going to start off with Pythagorean theorem. 50 squared plus b squared equals 53 squared. So 50 squared is 2,500 plus b squared equals 53 squared is 2,809. Move your 2,500. And b squared equals 309. It's kind of ugly. Square root of 309. I don't know that I can break it down a little bit at least. B equals square root of 309. We would have to go to a decimal there. Let's just call it 17.6 is what I'm going to put there. The other one I didn't go to decimal. I probably should have. Going to decimal, that would be 7.7. And you'll see in the answers because they're multiple choice what the options are. Okay? All right, now I'm going to find angle B. I'm going to use the adjacent and the hypotenuse because that's what they gave me. And I'm going to say cosine of B is equal to adjacent over hypotenuse. And I'm going to do my inverse cosine of 50 over 53. Going to equal B. So second cosine 50 over 53 is equal to 19.4. So if B is 19.4 degrees, I can find that last one by just doing 180 minus 90 minus 19.4, oops, 19.4, and that leaves me with 70.6 degrees for angle A. Okay? All right, so that's the end of the similar triangles and trigonometry final review. Happy studying!